right, ladies and gentlemen, good morning to you guys. Let's get this ready here. And I got to get the iPad ready. I seem to always have to do some of this stuff. A lot of work going on. Spring, 2022. Simplifying radicals. All right, simplifying radicals. So let me kind of express something to you guys here. It's kind of a big deal. It's kind of important here. Let me get this calculator out, right? So let me express this to you guys. You know, there's a lot of talk about a lot of things. Somebody asked me the other day that they're getting rid of the course, right? 125. You guys remember that last week? Somebody online, is she here today? Who asked that question? Or is she at home? Is she one of the bonbon people at home? Do you guys know? Let me share with you guys something interesting here. If I said to you this is a square, is that right? And maybe I should make this square bigger. I'm going to try to do it a little bigger. How's that? Something like this. I think it senses how to make a square. That's supposed to be a square. So maybe I have to learn a little better. Okay. This is a square. You guys okay with that? And then I'm going to say to you something like this, right? So the distance from each dot to each dot is 1 unit long, 1 unit. So, oh, there we go. Yeah. Hi, Daisy. Let me ask you. Good morning, Daisy. Good morning, Yasmin. Yeah, Daisy asked that question. So, hey, Daisy, where did you get that information? I'm just curious. How did you know that stuff? Just curious. Here's my square. Okay. Has to do with our lecture even. If this is 1 unit, you see this distance here, that's 1 unit. What I mean by 1 unit, it's a unit of distance. It could be a unit like a mile, an inch, a foot, a kilometer, and this is another unit. You guys okay with that? And there's a square, by the way. And then I'm going to say to you, let's ask you guys this question, see who knows. I'm going to say that there's this other distance here, and that's called a diagonal distance, right? Diagonal distance. Okay, I'm going to call that D for diagonal. Okay, thank you. Thank you, Daisy. All right. See that D for diagonal distance? Can I ask you guys this question? What's the length of that distance? What is the measure of D? How far is that? How do you guys think? How far? What would that be? Huh? Like this measures 1 unit, right? This is 1. And then this is 1. So in red, what's that distance? How long is that? That's the question. Do you guys know what I mean? How long is that? Huh? We got an option. Someone says, hey, Mr. Judge, I think it's 1. Okay, anybody have any other idea? People are saying, hey, that diagonal distance is 1 unit. And I'll say, no, it's not 1. Good guess, but it isn't 1. This is a measure of what's called diagonal distance. What else? What do you guys think? 1/2. We'll say, well, it measures 1/2. Okay, and the answer is what? No, that's not the answer either. It's not 1/2. It's not 1. Anybody have any other guesses? What might that diagonal distance be? 4? Okay, another guess here is 4. No, that's not 4. It's like, what's the length of that, right? You got horizontal is 1, vertical is 1. What's the diagonal distance? That's like the second most popular guess. Some people say 1, some people say 2. It's not 2. 3? Okay, no. No, this is what I'm saying. 5, 20, 30. You guys know what I'm saying? Here's what's important to know. You see, this is an ancient fact. People have always wanted to know, what is this diagonal distance, right? I mean, you can measure horizontal 1, you can measure vertical 1, but what's diagonal? What does that measure? That's a big question here. So human beings, mankind, has wondered about this distance for a long time. All right, you guys okay with that? They've wondered about it. Okay, so here you go. Well, here's what's interesting. You guys know this course, and you might say, hey, a counselor told me a week ago I was making an ed plan, and they said this course is gone. Hopefully not. There are people who are advocating that your courses be here, that these options be here for you. Because there's a lot of ideas and courses that you get out of mathematics that you use elsewhere. They're going to assume that for the most part, you either know it, or if you don't know it, they don't even care. Okay, you guys know what I'm talking about? And it has to do with even this question, because this question and the topic that we're studying, that we're going through, is very relevant about where your number system comes from. Okay, if you said to me, what are the issues with students who may have issues with mathematics? There's a couple of things. Number 1, it's arithmetic skills. Number 2, it's number sense. Number sense and arithmetic skills. Those are the things. And then there's some other issues that come up later in like a statistics course. There's like language, but it has nothing to do really, I shouldn't say nothing. It has something to do with math. They're related. Language and math are related, But anyway, this is an important detail. Very important. This is about the topic we're studying, and this is why it's important for you guys to learn this idea. Because this ancient fact is something that the Pythagoreans asked. What is that diagonal distance? And part of what you guys are supposed to learn here, and part of what they claim they claim you know how to do all these things. So, okay, Pythagorean Theorem. D squared is 1 squared plus 1 squared. You guys, maybe you might have seen that somewhere. That the diagonal distance is squared is 1 squared plus 1 squared. These are called the legs. And so you get d squared being 1 plus 1, or you get d squared being the number 2. So here's the real issue here. This equation that describes diagonal distance is a major part of this course, this very simple relationship. To say d squared is 2, the question becomes, what is d? All right, you guys with me on this? What is d? If you know d squared is 2, what is d? So mankind has been looking at this for a long time and wondering about the answer to this question. Well, guess what? Intermediate algebra answers that question. You see, we're going to study something called the square root formula. We're going to study it in detail. So d is going to be plus or minus the square root of a number 2. Okay, you guys know what I'm saying? Which one? Oh, yes, we got to talk about it. It's plus or minus. Yes, we got to talk about that. And you go, what do you mean plus or minus? Yes, mathematically speaking, there's 2 answers. You see this symbol? That means plus or what? Minus. And so there's two answers. Here's what I mean by that. That means D is either positive square root of 2 or D is going to be what? Negative square root of 2, because that's the meaning of of this symbol plus or minus. This is partly what you learn in this class. Plus or minus. That's partly what you guys are here for. Exactly what you're looking at here. So this is a great conversation for what's happening. And I guess the counselors at ELAC have a lot more information than we do. But here's the deal. Distance, ladies and gentlemen, is never negative. The idea of having negative distance, we don't really have that. We have positive distance. So the real answer here is this right here. Here's the answer. That the diagonal distance that you guys see here, this very fundamental question, D is the square root of 2. You guys with me on this? This is part of why you take intermediate algebra. And I know you go, what are you talking about? Well, you'll see as we go through the course here, right? But then the question becomes, you guys happen to know, we were working with this last week. The square root of 2, can you evaluate this? Say no, we can't evaluate it. Why can't you evaluate it? Right? The diagonal distance is the square root of 2. So why can't we evaluate that? Do you guys know? It's not on the list because what do you have to have here? Doesn't there have to be a perfect square? And what do you guys know about the number 2? It's not a perfect square. So you can't evaluate it. So I'm going to say this here. This 2 is not a what? Perfect square. Okay? This is why we had to learn that definition. So therefore, you cannot what? Evaluate the square root of 2. Evaluate is something very particular. In other words, when I say evaluate, this is what I mean by that. You guys can't apply this formula directly. That's what I mean. Remember that relationship? But here's what the Pythagoreans have been able to do. Let's use some logic here. Obviously, there is a diagonal distance value. Is that true? You can start to measure it with a ruler. If you got out a ruler, you can measure this thing. But you'll never be accurate because here's what we know. There's a very special group of numbers, very special group called the irrational numbers. Irrational numbers is what we're talking about. So the Pythagoreans discovered these special classes of numbers called irrational numbers. All right, so it gives rise to our number system. This is what I'm saying to people. In terms of fundamental knowledge and information, we have a lot of fundamental things that we do. We need to know how to measure things, how to use like rulers, and we need to know how to count numbers, right? We even need to know how to communicate what we know. Very fundamental to human beings, reasons, throughout the years. So you might say, what is an irrational number, Mr. Judge? Because that's what you're looking at. This is a special number. It's in a special category. So I'm going to have to express to you guys what this means, okay? So in order to do that, so I'm glad you guys are here today. And then you could go back and you can ask the counselors, hey, what's an irrational number? You guys know what I mean? Help me with that one. Irrational numbers. Well, in order to tell you what irrational numbers are, you know what I have to tell you what kind of numbers that exist first? Rational. Good logic. You guys know what I mean? So you might say, okay, by the way, what's a rational number? Definition. You guys know what a rational number is? This is our number system. Numbers that you guys use in a lot of places. A rational number is any what? Is any fraction. Remember how to go through set builder notation? What are you guys reading here? Remember set builder notation? It's a set of all what? What does this say to you guys? A over B. What is that known as? Yes, it's a fraction. A over B such that A and B are integers, signed numbers, and B could never be 0. You can never divide by 0. This is set builder notation along with what a rational number is. So if you ever hear rational, the code for a rational is any what? Any fraction. You guys okay with that? A fraction is a rational number. Let me give you guys some examples. Do you guys know if I said to you 1 over 3, you know what that is? Rational. Thank you. Outstanding, ladies and gentlemen. And then if I said to you, what about negative 2 over 5? That's also a what? Rational number. You guys okay with that? What about if I said to you 5 over 11? What is that? Rational. You guys okay with that? Is it a fraction? What about the number 6? It is. Why is number 6 rational? I can say 6 over what? Isn't 6 divided by 1, 6? So these are all what kind of numbers? Rational. Outstanding. Negative 4. Do you guys know something? Is it negative 4 divided by 1? Isn't that negative 4? You guys with me on that? So all of these numbers that you guys see, these fractions is what I'm saying here. But you can never divide by 0 because remember, the world breaks down if you do that. These are all called rational numbers, fractions. Okay, they exist in our world. We communicate with them all the time, fractions. And you can write every fraction as a what? As a decimal. Do you guys know that? How do you write fractions as a decimal? Anybody know what you do? You divide. You just divide. So if I take 1 divided by 3, right? I'm going to go to the TI now. Now, I can do my division. Don't worry about that. But 1 divided by 3. I want to show you guys something. What do you guys see there? Yeah, you get 0. What? 0.3333. And this goes on how? Does that go on forever? You guys know what I'm talking about? Do you guys see what I'm saying? So every fraction can be written as a decimal, and that's 0.33333 forever. That never ends. That decimal never ends. Interesting. Is that right? We're just looking at our number system, the mysterious number system. What about that negative 2 over 5? What do you guys think will happen there? So I'll put a negative 2 divided by a 5. What do you think we get? Negative 0. What? 0.4. Okay, you guys okay with that? Do you guys know what I'm going to say about this one? This first example, the digits never end. And what do you guys know about negative 0.4? The digits after the decimal, what do you guys know about that? Digits do end. Good. We say digits terminate. Terminate meaning they end. You guys okay with that one? The digits terminate. Oh, you guys are going to impress your parents tonight or your who? You go, no, miss, tonight for dinner, who do you have dinner with? My cat. You're going to impress your cat. You're going to impress your mom and dad. You're going to impress your brothers and sisters tonight over dinner. What about 5 over 11? You say, what did you do today? I learned about rational numbers and irrational numbers. What do you guys see here? What is this answer? 0.454545. Do you guys see what's going on here? This pattern, believe it or not, even though it ends there, I hate to say it, it's because you have a calculator and any piece of technology will end, but this actually never ends as well. If you actually did the division yourself, you're going to see the pattern never ends. So this is 0.454545. This is also the digits never what? Never end. They never terminate. Just so you guys know. Digits never terminate. 6 over 1, you guys know that's 6. The digits terminate. Is that right? Yeah, terminate. And then what's negative 4 over 1? You say, okay, I could divide that. The digits never terminate. So here's what I want you guys to know. This is a big deal, okay, in terms of numbers and number sense, because it's part of the course, intermediate algebra. Fractions either do one of two things. Here's a fact. Okay? A fraction either terminates when you do the division, right? Or when it never terminates, you guys know what you're going to see? Always, when it never terminates, or when it never terminates, there will be a what? Yes, outstanding. There's a pattern to the digits. That's going to be a key, ladies and gentlemen. Yes. There's a pattern to these digits. You might say, what's the pattern? Well, here it's 4, 5, 4, 5, 4, 5. You guys see what I'm saying? Over here, it's just what? 3, 3, 3, 3, and 3. This is the never terminating part, those three dots. And you say, what about 0.4? Well, this is a terminating situation. So what you guys want to know is that fractions, which are rational numbers, in terms of the decimal representation, they're either going to terminate or they're going to what? Have a pattern when they don't terminate. Those are traits of rational numbers. Yes. To the digits? Or when it never terminates, there will be a pattern to the digits. There will be a pattern. You got a pattern. So give me a fraction, ladies and gentlemen. Let me show you guys. Give me a fraction. Okay, we'll do 16 over 38. You guys okay with that? Oops. Now, here's the problem here. There will be a pattern, but what you're going to have to do is do some more division. So you have to get a better calculator. You have to buy a better calculator. So if I said to you, what about 5 over 8 instead? Does that, see this? This terminates. What about 7 over 8 instead? We won't pick big numbers or big fractions. That's 0.875. Okay. What about 3 over 8? Terminates. Okay. 3 over 10. What happens here? Terminates. 3 over maybe 11. What happens here? It doesn't terminate, but what do you see? You see a pattern. So every fraction of what I say to you will be a pattern situation if a decimal doesn't terminate, or you'll see it terminating. That's the real definition of a rational number. Okay, you guys with me on this one? Okay. Now let's go back to the iPad. Here's what I want to say. I want you guys to note this. Note. Better yet, definition. Definition of this thing called an irrational number. Irrational numbers, here's what they are. These are numbers whose decimal representation. So numbers whose decimal representation never terminates. And there is no pattern. No pattern to the decimals. This is what we describe as irrational what? Numbers. Okay? And there's a lot of irrational numbers, believe it or not. Your first irrational number that you guys see in your life, okay? Square root of what number again? Square root of 2. You guys okay with that? You told me that's irrational. How do we know? Well, let me share with you guys this. There are methods to deduce the square root of 2, believe it or not. They are, like in a geometry course. I remember when I was a kid, they taught us how to approximate this. You know, they don't teach that anymore. But anyway, what I'm going to do here is a second square root. You see this here, this 2? Here's my point to you guys. What do you see about this number? I know the calculator, because you bought technology, it'll terminate always. But this is a non-terminating decimal representation. Is there a pattern here? So there's no pattern there. So what I want to say here is whenever you have that kind of number, the best thing you could do ever with this is approximate. So if I had to approximate this to the nearest hundredths position, what digit is in the hundredths position? The 1. The digit to the right is a what? 4. If it's a 0, 1, 2, 3, or 4, what do you do when you approximate? You leave it alone. You guys okay with that? If the digit is a 5, 6, 7, 8, or 9, you add 1 to the 1 and you make it a 2. But since this case it's a 4, guess what that means? The square root of 2, which is an irrational number, is approximately, you have to approximate them, 1.41. You guys know why that's a big deal? Because you have a way now, go back up here. You have a way to say that this diagonal distance numerically is approximately 1.41. Okay, you guys with that? You see, that's 1.41. It's not 1, it's not 2, it's not 3, it's not 1.5, it's 1.41 approximately. More importantly, it's an irrational number. So what happened is that mathematicians, philosophers, you guys name it, they all studied this situation. And they found other irrational numbers. There's a lot of other irrational numbers too. Do you guys know what's another popular irrational number? Popular, most popular. We should call this the most popular irrational numbers. Maybe we should have a costume party and we all come as a irrational number. What do you guys think? No? No, Mr. Judge, I don't think that's too funny. Imagine you come as your favorite irrational. Oh my God. Yeah, I know. What did I just write down? What's this symbol? Pi. Do you guys know pi is another irrational number? Yeah, well, if we look at the calculator, right? Where's the pi? Okay, second, it's in blue right here. Here's pi. Here's my pi. What do you guys see as a value there? Yeah, I'm going to approximate pi. Pi is approximately 3 point what? I'll say 142. I'm going to go out to the nearest thousandths position now. So pi is another very popular irrational number, ladies and gentlemen. Where have you seen pi before? Anybody know? Pi, you know that number, this isn't a lot of calculations for a lot of things. Pi shows up, these irrational numbers show up in our calculations, in our science, in business, in mathematics. It shows up everywhere. Here's another famous irrational number. You guys don't know it yet. You're going to learn it in this class. It's called the what? You see this E? Do you guys know what that stands for? It's the exponential number. Outstanding, yes. You go, I've never seen that. It's another irrational number. It's an exponential number. So here you go, ladies and gentlemen. Let's take a look. And I'm going to find it in the calculator. It's down here. It's blue again. Second E No. Second e down here, I put e to the first power. You know what e is approximately? I'm going to say to you guys, e is approximately 2.7. I'll go out again to the nearest 1/8 thousandths position. Another very famous and useful irrational number that shows up in business and science. See, these numbers, whether we like it or not, they're a part of the world around us. They show up, they exist, and they've existed since ancient times, ladies and gentlemen. Exponential number. I'll put the name. Yeah, you have to learn about exponentials. Where do you learn about these? Math 125. What about pi? Where do you learn about pi? Geometry. You know what the definition of pi, though, is? Pi is if you take the circumference of a circle and you divide by the diameter of any circle size, you get this special number. You get this special ratio. So what I'm saying to you is in life and science and business, these special numbers and ratios exist whether we like it or not. They're around us. They exist. They're there. Do you guys see what I'm saying? So where do you learn about these numbers? Math 120 what? 5. So if they take it away, what will happen to you? You don't learn these numbers. And if you don't learn these numbers, let's think about this logically here. What happens really in life? If you take these courses and they talk about them, what's going to happen? Or they use them, what do you think will happen? You're not going to know them. So if you don't know them, what might happen? Well, you'll take a class and you say, Mr. Judge, I want to major in this. And I say to you, great, fantastic. I want you to major in whatever you guys want to major in. I actually want you guys to have any and every opportunity to become what you want to become. That's my personal feeling. I get to tell you guys, since I'm an old man, you know what happens with old men? Grandpa Judge gets to talk. Grandpa Judge, you guys know what I mean? Here's old man Judge. Let me tell you guys a little story here. When I was a kid, you guys know this already. I didn't do any homework. I didn't study. I came to this school called ELAC, and I started in Math 120, geometry. Then I took 125, this course. Yes, that's me, because I didn't do my homework. I had a friend, smart kid. His name was Salvador Fernandez. And I met him in PE. Now, Sal was a year older than me. And Sal, we used to walk home partly from school. Sal, he was from El Salvador. And he had some immigration issues, let's just say. But he was going to fix them. He was going to fix them by joining the Marine Corps. Right? That's how he was going to fix his immigration problems for himself and stuff. So he was going to go in. But Sal was walking around with a physics book. And I'm like, man, Sal, what kind of book is that? I didn't even know. I was looking at him with this book. I got impressed. So Sal was walking with this physics book. I was like, whoa, that's some serious information. You guys know what I mean? Physics is based on math. So with Sal, he was a year older. And Sal, because he was going to fix his immigration problems going in the Marine Corps, he says, hey, let's go in the buddy program. But he was a year older. I said, okay, you're going to have to wait. I'll go with you, but you'll have to wait a year. He says, I can't wait. I have to go now. So Sal enlisted. Now, after Sal completed boot camp, he called me and he told me two things. He said, you know what? Number one, he says, Dan, you know what? They hit you in the Marine Corps. I said, really? He says, yeah, they actually hit you. They hit everybody. Everybody gets hit. They got me in the restroom, the drill instructors. They hit me. I go, wow. I said, oh, my God. And then you know what else he said to me? He says, and they're sending me to El Salvador. I said, what? Yeah, we were fighting a war. Well, we weren't fighting a war. There was a war going on in El Salvador. And what people didn't know, and what people don't know sometimes, is we have these things called advisors. And sometimes if there's wars, we're not officially supposed to be there, but we are there. This is the truth. Some people might even be in Ukraine right now. You guys don't know. So Sal went to El Salvador to help fight there. And he told me, and I remember how he told me. So I never got a call back from Sal after that. His family moved. I lost touch. Never heard from Sal again. And I told Sal, call me when you can. Give me a call. He never called me. Don't know whatever happened to him. So sometimes I think that, if he were to just have more choices, if there were more choices for people, things would be better off. So when I think about some of this stuff and you say, well, no math 125, I look at it as removing choices. And then what happens to people if they don't have any choices? They might be tempted to have to be forced into other areas and things that they just don't want to be. So in the case of me and Sal, he should have been where? Here, going to school. Because he already had some skill sets, good skill sets to survive in school. I did not. I had to start in what? Remedial math and English courses. So I was grateful for the opportunity that they have given me, but now what's happening is they're taking those opportunities away. So that's where I worry. What happens when people don't have that opportunity or don't have the choice to take courses they need to be successful? They just simply end up where? Places they may not want to be. Just like who? My good friend Sal. And that's just the way it is. So when you learn this stuff, know this important detail. These topics are important because they describe the world around you. So the square root of 2, an irrational number, all that does is describe the diagonal distance. Something people have been looking at and wondering for a very long time, right here. And that's partly why this course exists, to teach you about your number system and where this stuff comes from. So you might say, why were we shading the all real numbers? You guys remember this? You say, why were we shading? Remember what did we call this line if I shade everything? You guys remember this? Yeah, that's called the what? The real number line. You guys remember that? And we said all real numbers. So, okay, here's this R. It represents all real numbers. You guys want to know something? All real numbers is the set of rational numbers united, married with the who? With the irrational numbers. Q, yes. Q is the letter that represents what? Rational numbers. What does the I represent? Irrational. So the rational numbers married with the irrational numbers creates your what? Real numbers, ladies and gentlemen. This is your number system. This stuff is ancient. This is called the Hindu-Arabic number system. Where does that come from? Where are Hindus at? India. Where is, what continent is India in? Asia, outstanding. Okay, Asia, and then where's Arabic? Where's that at? The Middle East. So you guys are looking at information that comes from the Middle East and India. They're the ones to give credit for our number system. Now, that doesn't mean other people didn't know about number systems. They have known. The Mayans knew about they had a lot of information, a lot of mathematics, a lot of science. The Mayans, you guys know that? But it got destroyed. The Spaniards destroyed their information. So there's a lot of people that have always gone back to Mayan civilization, study the Mayan civilization so they could determine what kind of math they knew, what kind of geometry they knew to do what they did. It's a big mystery. Wonder if they knew about the irrational numbers. What do you guys think? Did they know? These are real issues. These are real questions people have. Yeah, or they knew about something else that somehow described it. So that's the beauty of what you guys are here to learn and do. I think it's beautiful and fantastic. I know I scare people when I start talking this way. Like, what are you, beautiful, fantastic, wonderful numbers and number system? You guys know what I mean? People, that scares people. But this is where your numbers come from. They come from it's part of the Hindu Arabic number system. So we're going to start to study here in great detail these kind of numbers, irrational numbers. And that's why you're here in this course, ladies and gentlemen. They live on the real number line. Like this number 1.41, that's on the real number line, isn't that right? 3.142, 2.718, aren't those all on the real number line? They're there. So this is part of that real number line. So anyway, it's exciting for me to share with you all of this, but it has everything to do with what we were doing. Okay, now here's the problem though. If I said to you guys, evaluate the square root of 8, you know what's going to be the problem, ladies and gentlemen? Square root of 8? What's the problem? You can't. Good job. Why can't you evaluate that? You can't. Why can't you do that? Yes. Again, what's the problem? 8's not a perfect square. So 8 is not a perfect. You could evaluate the square root of 9. What's the square root of 9? 3. We can evaluate that, but we can't evaluate the square root of 8. So why you guys are here today is to learn something called what? We can simplify. Yeah, I mean, we'll do more work with those equations. See, part of the work we do, you might say, why are you talking about these irrational numbers? Because part of the work we do in algebra is solve quadratic equations. And when you solve quadratic equations, some of the solutions are irrational. So we have to learn what they are. Does that make some sense? And then some of your solutions are complex numbers. And you go, well, are we going to learn about complex numbers too? And I'm going to say, yes. So part of your world of intermediate algebra is to learn about number systems and where they came from and why. So that when you take those other classes, what's the deal? You're knowledgeable. That's all. Nothing more. Now, did you guys learn about this detail in high school in Algebra 2? Maybe, maybe not. Did I learn about it? No. Not everything that I show you here that I learned in high school. And I don't think things have changed since I went to high school. If anything, they've probably gotten what? Worse. Or have they gotten better? I have no idea. Maybe you guys don't know. I have no idea. Maybe they're better, maybe they're worse. I don't know. But I still think you guys need some what? Choice. Not to be cut off and placed in a situation where you may not be as successful as you could be. Now, just because you need more information, you need to learn, I'll tell you guys, there's no shame in that because that's where I was. And today, if I had to go through school today with what they have planned and want to do, I wouldn't be here. I know that for a fact. I would not be here. I just wouldn't. So I'm grateful for what was given to me, the opportunity. So what we're going to learn today here is how to simplify. Not evaluate anymore because we can't evaluate it. Actually, you can, but you have to take calculus and you have to take a lot more fees, take a lot more courses to do that. There's actually techniques that exist to find out what the square root of 8 is numerically. You know, those techniques, you know where they're at? They're in these what? Calculators. They're in these algorithms. In the calculator, there's these known techniques. But we're not there yet. We're just going to simplify our radicals. Okay, you guys okay with that? So we're going to simplify the square root of 8 now, but there's a process. Now, here's the deal. Here's the process. You guys ready? I'm going to give it to you in steps as a recipe. Okay? And it involves arithmetic. Darn it. Step 1. Here you go. You guys ready? Here's our first step. You're going to determine the largest perfect square that divides the number, I'll say divides what's under the radical. It's called the radicand, by the way, but the number under the radical with a what? 0 remainder. So I'm going to take this number. You see the number 8? What do I need? Do you guys know what I need? I need to know about what? Perfect squares. Have you guys ever seen a perfect square before? Say yes. You go, what do you mean? Well, I'm going to have to go back. We're going to go back. Okay, go back where? Where we have square roots. There we go. I'm going to have to copy. Here we go. Let's go copy this stuff. Here we go. Here's some perfect squares. Is that list still by the refrigerator? Do you guys know what I mean? I hope it is. Is that still there? I hope you guys still have it. Is that still on your screen share, whatever it is? No, you guys know what I mean? I need the largest perfect square that divides what number? 8. Okay, where are they? Yeah. What's the largest perfect square? So 8 would be, let me put it down here. Wouldn't 8 be somewhere here? Oops. 8 would be somewhere over here, is that right? 8 would be between 4 and 9. Is that true? So we're going to be systemic. We're going to be smart about this. Always check the perfect squares that are prior. You go, what do you mean? You see this right here? 4 is a perfect square. Does it divide 8 with a 0 remainder? Let's do some division. Okay. 4 has to go into 8 with a 0 remainder. This is what I mean. How many times does 4 go into 8? Do you guys know what you call 2? That's the quotient. 2 times 4 is 8. Subtract a 0 what? A 0 remainder. So you're saying, is this step 1? I'll say yes. You found the perfect square. What's the perfect square? It's 4. And so here's going to be step 2. Step 2. You're going to write, what do we say the number was called under the radical? It's called the radicand. Write the radicand as a product of the largest perfect square and the quotient found in step 1. Okay, so here's that radicand, here's the 8. How are you going to write that 8 as? 8 equals what? What was that largest perfect square? 4. So we're going to write this as 8. 8 equals what? 4 times, and then what do we know? The perfect square and the quotient. What is the quotient? 2. Isn't it true that 8 can be written as 4 times 2? 4 times 2 is 8. You guys okay with that? We're almost there, ladies and gentlemen. This is the hardest part. This part is the hardest. So let me color coordinate this. Yes, 8. I'm going to go through the details. 4 is your perfect square. 2 is the quotient, right? And then you see this thing, that dot? What does that dot mean? That's product. It means to multiply. That's the hardest part. The first part, step 1, is the hardest part. But this is why you want to know the what? You want to know the list, the perfect square list. You want to, how many times you go to the refrigerator again? Like me, unfortunately, 20 times a day. What do I get? Yogurt. Where's my peanut butter and jelly? Had it in my office while they fumigated the room. Yogurt, peanut butter and jelly. What else? Some meatballs, some milk. Leftover meatballs. You guys know what I mean? You guys like meatballs? I know I do. Meatballs. All right, you ready for step 3? Step 3. Here you go. Step 3. Use the product rule for square roots. To evaluate the perfect square. You go, the perfect square, I'm going to put that in green. So let me show you. Right? Remember, what's the original question? Square root of 8. We write 8 as 4 times what? 2. You guys see what I mean? Here's that 4. That's what we're going to look at. What does the product rule say? You guys remember the product rule? Right? You take the square root of 4 times the square root of 2. Because what do you guys know about 4? It's a perfect square. And you're pretty much done, ladies and gentlemen. Why do I know you're done? 2 times what? The square root of 2. Yeah, but you just leave it the way it is as the square root of 2. Because the square root of 2 is a symbolic number. Like E is a symbolic number. Pi is a symbolic number. Yes, square root of 2 is approximately 1.41. But this is the symbolic answer. This is what they want you to do to simplify the square root of 8, ladies and gentlemen. There it is. That's the process. That's the process. Now, just because I showed you how to do the process once, does that mean you know how to do it? No, because what do you have to do? Practice, practice, what? Practice. You guys ever hear of Magic Johnson? You guys know, here's the problem. When I was a student, I had to figure out how to study. I didn't know how because I never did it in high school. So like, how do I study? Then I was listening to Magic Johnson get interviewed. You know what Magic said? Before he got up in the morning and brushed his teeth, he made 100 free throws. He tried 100 free throws every day before he brushed his teeth. Do you guys know something about Magic Johnson? He was a very good free throw player. But what did he do? You see, it was always funny because I used to watch Magic make his free throws, and I'd go, my God, Magic is such a blessed guy. He can make free throws like you wouldn't believe. He had a free throw rate of like 84, 85% or something. What about Shaq? Was he a good free throw? No? You guys know Shaq didn't make his free throws very often. Magic Johnson did. But he did what? It wasn't necessarily skill. It was what? Practice. So I actually looked at that and said, oh my God. You mean if Magic Johnson has to practice doing free throws to get good, then I guess I have to practice doing what? Math to get good. It's just that simple, ladies and gentlemen. That's all. So you might want to verify. I'm going to share with you guys. Here's my point again. Square root of 8. Second, square root of 8 numerically is 2.8 blah, 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 right? It's an irrational number. What is 2 times the square root of 2? You know what you're going to get? Yes. You should see that it's what? The same thing. That's what I'm saying, that the square root of 8 is 2 square root of 2. But 2 square root of 2 is a simplified answer. And that's what our process is, to simplify. Exactly. So that's why we're here, ladies and gentlemen, to simplify this. Now, there's other classes that you're going to be taking, hopefully, that do this. Now, I actually recommend to you guys, I don't say to you guys things like, you know what? You should major in something that's easy. What's an easy major? Is there an easy major? Is there such a thing? I have no idea. What do you think might be easy? This is about your perception, not mine. PE? What do you got to do in PE? Work out? Oh, well, some of us will fail that one, right? Believe it or not, I used to be very fit. If I showed you pictures, you go, oh my God, that's Mr. Judge? Yeah, I used to be very fit, believe it or not. I'm going to have to find some pictures. Maybe I'll show you guys. Find them on my phone. Oh, some of those videos? Yeah, you're right. Oh, there you go. Good job. Yeah, that's right. Some of those days, yes, you're right. And it wasn't that long ago, by the way. You're right. That's true. Some of those algebra videos. Okay, what's my point again? I think I had a point. But when you get old, you forget your point. What's the point? Anyway, square root of 12. We're going to simplify it. Yeah, easy major. You guys know what I mean? Because sometimes what I hear, it's kind of heartbreaking. I hear people say to students, don't major in that. That's too hard. It takes too long. Major in this. That's easy. Oh, they tell you that? Major something easy? Okay. Oh, they tell you all the time? Why do they tell you that? Just curious.
Because they say it's like, oh, too much money, get a short career, you'll be out in no time, and it's like, that's not what I want to do.
Well, I don't know. I mean, I'm gonna, like I said, I'm gonna tell you guys things I tell the people I love in my family. I have to. I think I owe that to people. I don't think I can't be that person that just does what? Lies to you and just walks away. I think here's the deal. You major in things that are going to feed you. That's what you do. See, I'm more practical in that way. I mean, my parents were artists. And you know what happens when you major in art? No offense if you're going to major in art. You go, oh my God, Mr. Judge, I'm going to break down here. It may not feed you. How do I know? Because I was hungry as a kid. That's how I know. My parents, they were art majors. And my dad, whatever. I don't have to go through the long story of it all. But I think, like I said, major in something that's going to feed you. That's important. And if something that's going to feed you takes more time and energy, then what? Then do it. That's the way to go. If you major in something you think is short and simple, you may come out with all the people that major in things that are short and simple, and now what's the story? You're trying to compete for a job that there's a lot of people out there who can do. And then what happens is it becomes who you know, not what you know. And if you're a kid like me, I didn't know anybody. No one. Zero. So that's what I've learned. That's the long lesson that I've learned, is do something that's going to feed you. Doesn't mean it's going to be easy, but it'll be worth it. Because I have had students come back and tell me, Mr. Judge, I majored in something. They came back, and I don't have to mention majors, but they came back, and I said, you're still here? And they go, no, I finished. I said, well, why are you back? I said, because what I majored in, I made more money at Walgreens than what I did in what I majored in. I said, are you serious? They said, that's what my students tell me. They're not telling me that today. They're telling me that 10 years ago. So 10 years ago, this is what they were telling me. So I'm just wondering now, what the deal is. You guys know what I mean? So it's a crazy time with crazy things going on. And I'm now at the point where I can say, I'm not sure what to tell you now because of how insane and illogical things are. It's crazy. Yes? Yeah, I know. But I'll tell you know how long I was at ELAC? You guys want? I'll tell you guys. I'll tell you. I was here for 4 years. 4 years. I was an ELAC student for 4 years, and then I transferred. Then it took me another 3 years to finish with a bachelor's degree. Yes. So I was one of these 7-year bachelor's people. Oh, poor me. You guys know what I mean? Because I had to start in what? Math 120. That's okay. It's not. I'll tell you guys what I tell students. This is the most important thing that you'll learn today. It doesn't matter where you start. What matters is where you end, ladies and gentlemen. That's the most important thing. It's not where you start, it's where you what? Where you end. My younger brother, ELAC student 2, engineer today. Both him, because we wanted to eat. That was what me and my brother were like, oh my God. You know what we did? Sometimes if we found some money somehow, somewhere, we want to go buy food to eat. That was our treat. I'm going to go eat something. Go eat a bean and cheese burrito at J&S. Get it for $1. Not anymore. You guys probably don't even know where J&S is. No? I used to eat a lot of bean and cheese burritos if I was lucky. Get a bean and cheese. Well, okay. We're going to finish more of this tomorrow, but I know you guys are chomping at the bit to jump out of here. That's not you guys. You guys are in Math 125. So what I'm going to share with you guys here, if you guys want to get started, we only seen one example, but we're going to see more. Tomorrow, this is simplifying, where are we at? This is called simplifying radicals. We're going to do more. Okay, we're going to do more come when? Come tomorrow. So Daisy, I hope you got some good advice, Daisy. Here you guys are. Okay, so let's go over here now. And I'm going to do now here. We're going to look at this example. This is where we left off. So it looks like we got a few people here. Ardix, good morning. And Daisy, good morning to you. Okay, we got Mikhail, good morning. So we got a number of people there at home. Good morning to you guys. Now, the instructions are going to say here to do what? To simplify the square root of 12. Okay? And what you have to do is follow that procedure I gave you guys, right? So step 1, we need the largest perfect square. Let's erase. 12, where would 12 be? 12 over here would be where? It's between 9 and 16. You guys okay with that? So I would say to you, again, that first step, we need, what do we need? It's right here. Determine the largest perfect square that divides what number now? What's the number? 12, is that true? With a 0 remainder. So what I would say is work backwards. Let me share with you guys what I'm talking about, right? Yeah, picking up where we left off. It's just we have to do the square root of 12 now, right? So 12 is here. What's the perfect square that's prior to 12 here in this list? What do you guys see? You guys see 9? You guys see that there? Okay, how many times does 9 go into 12? Once, right? 1 times 9 is 9. Subtract. What's your remainder? 3. So guess what? 9 is not the perfect square. Okay, you guys okay with that? So it's not 9. All of these are the perfect squares, so maybe I should change the colors here. Okay, so these are all perfect squares. We tried 9. We're going to try what now? We're going to try 4. Work backwards there. You guys with me on that? So now 4 goes into 12 how many times? Okay, 3 times. What's 3 times 12? What did you get? Anybody notice what you got? What did you get? You got the 0 remainder. What does that mean, ladies and gentlemen? That's what you're going to use here, okay? But now, what does step 2 say? Remember, you're going to write this 12 as 4 times what? Times 3. So this is step number 2 now, okay? You write the radicand, which is 12. Which was the largest perfect square that just went into it with a 0 remainder? 4. Good. What was the quotient? Go back up here. You see this number here? You see the 3? That's your quotient. Okay? That's the answer that you get when you divide. So here's what I'm saying. 4 is the largest perfect square that goes into 12 with a 0 remainder. And then you have the quotient being 3. So if we said, is this the perfect square? Yes. And is this a quotient? Yes. What does step 3 say? Yeah, you guys know, use that product rule. In other words, to take the square root. So in other words, this will be the square root of 12 is the square root of 4 times 3. So here's my 4. Here's my 3. Square root of 4. Square root of 3. What's the square root of 4? So the answer is 2 times the square root of 3, ladies and gentlemen. There you go. And good morning, Exotic. And good morning, Karen. Good morning to you guys. 2 times the square root of 3. So that's the process that you guys want to do. You get the largest perfect square, and what do? You want to find which one's the largest perfect square that actually what? Goes into the number with a 0 remainder. Let's give you guys another example. Let's give you a hard one, like the square root of 50. And you guys go, oh my God, the square root of 50, right? So where is that 50 at? Right? All of these numbers are perfect squares. Yeah. 50 would be where? Yeah, I look at it this way, right? And then you know what you do? You check all of those green numbers. Those are perfect squares. Check to see if they divide 50 with a 0 remainder. It has to have a 0 remainder. So what's the first perfect square after 50? Go backwards that way. Don't go forward. 49, right? Good. So you're going to try what? 49. That's going to go into 50. How many times? 1 times 49. What's the remainder? So that's not it. Has to have a 0 remainder. Okay, check the next. What's the next perfect square? 36 goes into 50. Once again, 1 times 36 is 36. Subtract. What's the remainder? Isn't that 14? What do you guys know? That's not it. That's not it either. So notice we're checking the perfect squares. We're working backwards. What's the next one? Okay, 25. Does 25, it is a perfect square. It's on the list, right? How many times does 25 go into 50? 2 times 25 is 50. Subtract, you have a 0 remainder. Isn't that what we're looking for? Yes, this is the situation. So what I want you guys to notice is this. Here's what we want to do. This is the quotient. This is the remainder. 50 is written as 25 times what? 2. Perfect square. Quotient. You guys okay with that? That is what we're putting right here. And then, what do we put here? You guys know what we're putting? That's going to be now. What do we do with this now? Yeah, we're going to check the square roots now. So I'm going to copy that. Square root. Square root. Product rule. Product rule. What's the square root of 25? 5. So this is 5 times the square root of 2, ladies and gentlemen. There you go. You're done. 5 times the square root of 2. What do you guys think? You guys see what I'm saying? You got to go through this process. And at first you might say, oh, that's a long process. I know. But after a while, you do them over and over again, what starts to happen? You start to know about these numbers. You go, oh my God, okay, yeah, I can break it down that way. And good morning, Fan for Life. Good morning to you as well. All right, let's give you guys some more. How about the square root of 18? Could you guys do the square root of 18 now? 18. Where would 18 be amongst the perfect squares? I think it's right here. You guys okay with that? Between 16 and 25? Okay. So we're going to take the square root of 18. We're going to try to simplify that. Okay. Does 16 go into 18, right? We're going to check these perfect squares. How many times does 16 go into 18? Once. 1 times 16 is 16. Subtract. What's your remainder? So this isn't it. We don't want that one. So look at the next perfect square after that one. 9. Does 9 go into 18? How many times? 2 times 9 is 18. Subtract. What's your remainder? And you know what something? You're right here. That's it, because you're going to have, this is the 9. That's the largest perfect square that goes into 18. Here's my quotient. So you know what? You know what you do? What do you say? 18 is, write the perfect square before the quotient. Okay, you're looking at the information already there. Is that right? So this is what we're looking at now. Remember, what do you do now? Square roots, right? What's the square root of 18? It's 9 times 2. 9 is the largest perfect square that goes into 18. Okay? Product rule. Square root of 9 times the square root of 2. 9. 2. What's the square root of 9? 3 times the square root of 2. And you are what? Done. Okay, you guys okay with that? What you're going to notice is we're going to leave back the quotients every single time. You guys notice that? See if you're awake. Should we have you guys try some? You guys want to try them on your own? Okay, let's going to try some on your own. Square root of 27, number 2. Square root of 32, number 3. Square root of 24. And number 4, square root of 6. So I'll give you guys some time to try these out on your own, okay? See what you guys, oops, no, not 2 minutes. Change that. Just give you guys some time. There it is. Here you go. All right, ladies and gentlemen, let's take a look. Okay, we're going to try these out. Okay, you guys okay with that? You want to follow the process. What's the largest perfect square that goes into 27? Okay. Does everybody agree that it's 9? Okay, good job. I believe you're right. It's going to be 9. That's the largest perfect square. What was the quotient? Good. It is 3 here. Okay, it must be the largest perfect square. It can't be just any perfect square. Okay, now the product rule says the square root of 9 times the square root of 3. And what's the square root of 9? This is 3 times the square root of 3, ladies and gentlemen. So here's your final answer. I just want to always remind you, the quotient will always be left under the radical. Okay, you guys okay with that? Good job. Let's see if you guys did the next one. The next one might be hard, right? Give me the largest. It has to be the largest perfect square that goes into 32. I think you're right. 16. What was the quotient? Outstanding, ladies and gentlemen. It is 16. And the quotient is 2. Good job. Square root of 16 times the square root of 2. So, ladies and gentlemen, square root of 16. What's the square root of 16? 4 times the square root of 2. And there it is. There's only one answer. Yeah, but go back. That's a good question. Some people say, what about 4 times 8? That one works. Yeah, but what does step 1 say? Yeah, it must be the what? The largest perfect square, not any perfect square. So if you said 32, right? You say, was it number 32? So here's my advice to you guys, right? 32 would be here. So my advice is this. If you need the largest perfect square, once you locate where 32 would be, work backwards. In other words, check first what? 25. 25 goes into 32 once, but the remainder is not 0. Is that right? Then check 16. So notice, if I work backwards this way, I'm guaranteed to get the what? The largest, and that's what we need. That's why it's 16. So you say, yeah, 16 goes into 32. It goes in twice. 2 times 16 is 32. And sure enough, yes. Let's color coordinate this. Perfect square. What's this? Remainder. What's this? Quotient. So it will be 32 is 16 times 2. Which means it's the square root of what? Product rule. And this will be 4 times the square root of 2. So ladies and gentlemen, that is, always work backwards in that way. Always, always, what's the word? Always. Good. Because that way you're going to be guaranteed to get the, what's the phrase? You're going to get the largest perfect square. Has to be the largest. Okay, good job. Now, what about 24? Did you get the largest perfect square that goes into 24? Yeah, what is it? 4. What's the quotient? 6. Yep. You guys are correct. 4 and what? And 6. You guys are correct. Use the product rule. What's the square root of 4? This will be 2 square root of 6, ladies and gentlemen, and you are done. Always remember, what is left under the radical will always, always, always be the quotient, just to let you guys know. And then, what do we know about this square root of 6 here? Well, yeah, you might say, Mr. Judge, I went through your process, your procedure. Where would 6 be? Yeah, 6 is right here between the 4 and the 9, right? So which one are you going to check first? 4 and then what? 1. So we're going to check 4. And you might say, 4 goes into 6. It sure does. 4 goes into 6 how many times? What's 1 times 4? Subtract, what's your remainder? So it's not this one. No. Check 1, that's the next perfect square. You guys know 1 goes into everything with a 0 remainder? 1 goes into 6, 6 times 6 and 1 is 6. Subtract. You guys know, what is this? It's a 0 remainder. So you might say, do I write this as 6 equals 1 times 6? And I'll say, yes, you can. Perfect square. Quotient, there's your quotient. And then, what do you get? Square root of 6 is the square root of 1 times 6. Square root of 1, square root of 6. This is going to be, go, square root of 6 is square root of 6? Yes. What, you guys know what that means? Here's what it means. It was already what? Simplified. Yeah, if the largest perfect square that goes into it, it has to be the largest, is 1, then it's already what? Simplified. Yes, that one's already simplified. Yep, it's always going to be what you started with in the question. So like, for example, I'll give you another example here. You might say, what if they gave me the square root of 5? Well, what's the largest perfect square that goes into 5? 1. Then it's already what? Simplified. Good. Square root of 2. Already simplified. The largest perfect square that goes into it. Square root of 3. Largest perfect square is 1. Well, what about square root of 10? What's the largest perfect square that goes into it? 1. Then it's already simplified. Square root of 15. Largest perfect square that goes into it is 1. Okay. Square root of 30. What's the largest? It has to be the largest. It's also 1, by the way. So there's actually a lot of radicals that exist there that are already simplified. Okay, but you have to find, every one of these has this problem here. That when the largest perfect square that goes into a number is 1, if that's the largest, then it's already a simplified radical. Is that kind of interesting? Okay, let's give you guys some more here just to kind of check you guys here. This is the 4. We're going to do number 5 here. Square root of 22, 6. Square root of 26, 7. Square root of 28, 8. Square root of 72. We'll give you guys some time for these as well. Let's see what you get. Ah, okay, ladies and gentlemen, let's try this out. You guys ready? 22, largest perfect square that goes into 22. Well, be careful here. Let's go back. 22. Let's go over here. Right? Which one is the perfect square list? In green or non-green? Right? Because 22 would be over here. Is that right? Oops. Right? Which ones are the perfect squares? The numbers that are in green. So what's the first one you want to check? 16. Oops. Where do we go? We're going to check 16. Sixteen goes into 22 how many times? Once. What's 1 times 16? Remainder is 6. It's not 16. Is that right? So you check this one. Now you're going to check 9. And you say, we're going to check 9. Does 9 go into 22? Twice. 2 times 9 is 18. Remainder is 4. What kind of remainder do you look for? Okay, so this isn't it. Now check 4. How many times does 4 go into 22? Okay, 5 times 4 is 20. Subtract, what's your remainder? So you checked all of them. 9, you check 16, 9, and 4. 1 goes into every one. So what do you guys know? It's 1. That means it's already what? Simplified. Okay, already simplified. There you go. Already simplified. What about 26? Already simplified? So for 22 and 26, the largest perfect square that goes into it with a 0 remainder is 1 for both of these. Okay? So now you go to 28 now, right? And you say, what about 28? So 28 is still going to be, oops, no. 28 is over here. $25 goes into 28 how many times? $25, subtract the remainder is 3. It's not 25, right? Now check 16. Work backwards, ladies and gentlemen. Now check 9. It's not 9. You got to check now what? Was 4 going to 28? 7 times 4 is 28. Ah, we got a 0 remainder. Guess what that means? This is the largest perfect square. It's 4. All right. Okay, so what do you write down again? 28 is 4 times 7, where 4 is your largest perfect square. 7 is the quotient, ladies and gentlemen. Okay, so notice what I did. I went through the process backwards like this, right? That guarantees to give me the largest perfect square. Now, square root, product rule. Is that right? Square root of 4, square root of 7. What's the square root of 4? Okay, so that's going to be a 2 times square root of 7. Ladies and gentlemen, there you guys go. Pretty good? That's the process you want to go over and over again. $72. What happens here? Square root of, what's the largest perfect square that goes into 72? Think again. Largest perfect square. Anybody get it? Well, how would you do this process? Yeah, we're going to locate where 72 would be, right? Yeah, 72 is somewhere over here. So you're going to check 64. 64 goes into 72, but do you have a zero remainder? No. Now check 49. 49 goes into 72, but do you have a zero remainder? No. 36 goes into 72. Do you have a zero remainder? Yes, you do here. So you say, what do you mean? Let's try this out. I'll share with you guys this. $36 goes into 72. How many times? 2. 2 times 36 is 72. What's your remainder? So here's 36. Here's your quotient. Yes. You had the zero remainder. Okay, so that means 72 is written as 36 times what? 2. Largest perfect square. Quotient. So that's the process you guys do. All right, so we're going to go, okay, here, we're going to put this square root of 72. We're going to use now the product rule. Square root of 36, square root of 2. What's the square root of 36? So it'll be 6 times the square root of 2. And ladies and gentlemen, you're done. There it is. There was an extra step. Yeah, I would recommend you go with this all the time. Largest perfect square, personally, so you don't make those mistakes. That's my personal. And then I'm going to remark something about you guys here. You can simplify the variables the same way. Okay? So all of these can be simplified exactly the same way. So if you said, what about x to the third power here? Now remember this. These examples. First of all, if you have a variable, what kind of power do you need to have to evaluate? You guys remember? You had x squared, x to the fourth, x to the sixth, x to the eighth. That lists forever. These are what? Yeah, even powers, but they are perfect what? Perfect squares, right? Okay, so you go, how did I know? Well, when you actually created the list, we put x squared, x cubed, and so on, right? That list. So if I take x and I square it, x squared squared is x to the fourth, x cubed squared is x to the sixth, x to the fourth squared is what? X to the eighth, and so on. You guys remember, these are all the perfect squares, so we can take the square root of those. So you might say, why did you do now all the odd powers here? Because we're going to do this phrase called what? Simplify. So x to the third, if I looked at this first one, you know what x to the third would be? It would be right in here. Is that true? It's between x squared and x to the fourth. So between x squared and x to the fourth, you have x to the third power. Now, remember how we were checking the largest perfect squares, the prior ones? Try to do that. This is what I mean. If you take x to the third and you say, we're going to divide that with x squared, the perfect square. Do you guys know what that is? Let me share this with you guys. These are the same problems. X to the third over x squared. This will be x to the 3 minus 2 by properties of exponents, which is x to the first power, or what? Just x, yeah. So here's my perfect square, and this is my quotient, ladies and gentlemen, Q. So that my x to the third power is written as x squared times x, where perfect square, and then my x is the what? Is the quotient. So these are actually easier, ladies and gentlemen, a lot easier. Okay, you guys with me on that? And then you take the what? Square root of these. And then, what do you guys know about the square root of x squared? Just x. So this is x times the square root of x. And you're done. There you go, ladies and gentlemen. What do you think would happen for x to the fifth? You guys know what will happen if you had to simplify the square root of x to the fifth? Right? Where would x to the fifth be on this table? Yeah, it'll be where? Right here between x to the fourth and x to the sixth, right? Do you guys ready for the answer always? You know what it's going to be? The prior perfect square always. In other words, what's the prior perfect square here? Prior means before. X to the fourth. So if I told you guys, x to the fourth, that perfect square, when I use properties of exponents, right? You know what you get? You get x to the fifth minus 4, which is x to the first power. Again, this is my what? This is the quotient, ladies and gentlemen. So it's always, always, always going to be the prior what? The prior problem. So you're going to get now x to the fifth, x to the fourth times x. Perfect square. And then what's this? Quotient. Take the square root. Square root of x to the fourth, square root of x. What's the square root of x to the fourth? Yep, this is x squared square root of x. All right, you guys okay with that? Pretty simple. What about x to the seventh? What if you said, no, Mr. Judge, I don't like x to the seventh. I want to see y to the seventh. Well, it's the same. What do you think I'm going to write this as? Y, the prior perfect square is y to the sixth. Is that true? You guys see what I'm saying? Y to the sixth, and then that's going to be a y. Then you take the square, you use product rule. What's the square root of y to the sixth? Right? Remember, what do you do with this? Ain't that 6 divided by 2 again? You guys remember that one? So what's 6 divided by 2? It's y cubed square root of y. Z to the ninth. What's the largest perfect square? It doesn't matter what the letter is. What's the largest perfect square? What's the perfect square that's prior to z to the ninth? You guys know what's the z to the eighth, right? So you put z to the eighth times again z. Yeah. Oh, because remember that I gave you guys that fact about how to take square roots? Remember this index? What was the index here? This is 2. So if you guys remember that fact, you take the power and you divide by the index. Okay, you guys remember that one? You said, what do you mean? Here's what you're using. Square root of x to the even is x to the even divided by 2. So that should be in your notes. It doesn't matter if the variable is x, y, or z. Product rule, z to the 8th, square root of z. So notice the colors here, right? Perfect square. It's going to be the largest again, and then this is going to be the z. So using this fact I just showed you guys, what do you guys write down? Right? Get rid of the radical. It's now going to be z to the what power? Z to the 8 divided by 2. Right? You say why 2? Because the index here. These are square roots. So for square root, the index is 2 always. So this is z to the what power? 4. Good. Square root of z. All right.
Oh, I see. So whenever we divide by 2, that's when we're taking the square root,
Mm-hmm.
and we only subtract when we're like adding exponents.
Let's see, w to the 23rd. Let's see if you guys figure this one out. Is 23 odd? What's the largest perfect square that goes into w to the 23rd? The prior one. 22nd. You guys okay with that? Always. And this is going to be what? W. Perfect cube. What is this? Quotient. So it's always going to be the prior. W to the 22. Square root of w. Always prior, ladies and gentlemen. W22 square root of w. But how do you actually, remember, how do we actually evaluate this? Yeah. And there you go. What do you guys think? Is that pretty good? Should we try one more? What's your favorite letter? L? Okay. L to the 47th power. You go, oh no. It's very simple. What's the largest perfect square that goes into L to the 47th power? Sometimes the silliest examples are the ones you remember the most. So what color do we color? Green, and then what? Yeah, I think you're right. What do you guys have here? Square root of L to the 46. Square root of L. Which one? Oh, 46. So we can put L to the 46. Now, what do you guys do to evaluate that radical? Divide by 2. Is that right? So I have to know what 46 divided by 2 is. 23. Good. There it is, ladies and gentlemen. So what I'd like to say is we go back here to worksheets and videos. What is this? Do you guys know? Simplifying what? Radicals. Simplifying radicals, ladies and gentlemen, a very important process. I want you guys to work on these. I believe I put the homework in the Canvas section for you guys.